For number 17, all we're doing is some matching with the properties, definitions, theorems, or postulates given in this list. So for the first one, the measure of angle 1 is equal to itself, the measure of angle 1. If you remember, I related this to looking at your reflection in the mirror, you see yourself. So that would be the reflexive property. So that's F. The next one, if you look at what's going on, they're relating three different segments. They're relating AB, CD, and EF. So they're saying AB is the same measurement as CD, but then CD is the same measurement as EF. So you can conclude that the first and last, AB and EF, were the same. If you cross out what they have in common, you're left with the final statement, AB and EF being equal. That would be transitive property whenever you relate three things and can cross out what they have in common. For the next one, we have an equation, and then suddenly the equation has x isolated. So how would you isolate the x? How would you move that 5 to the opposite side? Because it's positive 5, you would subtract. So this would be the subtraction property to isolate the x. And the next equation here, we have on the left side, we have 3 times AB. And if you look at the final equation, suddenly AB is alone. So how would you get AB alone if there's a 3 attached? Squish together to the AB, multiplication. The inverse would be divide both sides by 3. So that would be D, division property. If you look at the next one, we're relating a segment, XY, that's congruent to MN. And then they say the measurement then, XY is equal to MN. So they change the signs here from congruence to equals. That would be definition of congruence. And the next one, we have EF is equal to GH. And then suddenly, there's a lot going on in the next equation, so I usually pick a side. EF is alone here. And then on the left side in the next equation, suddenly there's an AB being added to it. So if you look at the original and the next equation, AB is being added to both sides. What says you can add anything to both sides as long as you stay consistent and add the same thing? The addition property, so A. The next one, if x is 9, then 5x equals 45. So the original equation looks pretty simple, but then suddenly there's a 5 attached to the x. So on the left side, x is alone, and now suddenly there's a 5 attached to it. That would be by multiplying by 5, so multiplication property. And last but not least, if C is between A and B, maybe you want to draw a picture for this one. They didn't say the midpoint, they just said in between. So C is between A and B, then AC plus CB is equal to AB. What says you can add the two smaller segments to get the larger? That would be the segment addition postulate.